Okay, double broadcasting for a moment. And single broadcasting. We're going to be inception as soon as we go live. And single broadcasting. We're going to be inception as soon as we go live. Today is March 3rd, Wednesday. This is CS-030. Today is March 3rd, Wednesday. This is CS-030. Today is broadcast 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 3rd, Wednesday. This is CS-030. It's like a loop machine. It's like a loop machine. Okay, enough of that. All right, so let's see. Single broadcasting, we are in class. I'm gonna do a couple things with you. Okay, first thing, let's walk through our checklist. And actually, I'm going to go over and go to our checklist board because I've got a slightly modified checklist, and we've got some things to do over there. So if you could join me in the checklist board. Let me fix this up. Okay, double broadcast for a second, and I'm a single broadcast. All right, we're broadcasting on YouTube. Just to reiterate, for the purposes of the recording, we went through a new checklist that's over there by Dodger, and it doesn't. If you click on it, you're not going to get the most current checklist, but I'll update that after class. But what the checklist includes is it includes a new reminder to check in on the attendance board. The attendance board I'm zooming in on right now. Ethan said he hadn't quite seen the checkbook, the attendance board res in yet, and so hopefully by the end of class he will see the attendance res in. So that's the attendance board there. What you do is you click on the white dot and it will reveal your name, and then I can take attendance pretty easily without having to monkey around too much with finding where you are in game. It does require that you remember to go over there and check in though, but I'll remind you. And at the end of class, after I've taken attendance, I'll reset them all. So that's how we'll handle that. Fax machines for handouts over on the right. If you want a handout, you can go over there and click on the fax machine and it'll throw a document. And then if you click on the document, it'll take you to the result in game or in Google Drive if you're sharing it. Okay, let's see. All right, I'm just scanning our front row. It doesn't look like anyone's taken over by animations yet, but maybe they'll switch. All right, let's what should we do? Let's open in prayer just quickly. Dear Heavenly Father, thanks for this fun environment in which to have a class, even though we've got all kinds of other things going on. We are grateful for the vaccines that are coming to the most vulnerable among us, Santa Barbara and the rest of California for sure. We pray for those places that are having trouble getting it, that you would keep people safe until they're able to get it. And we pray that the vaccines would not cause any damage themselves as well. Keep us healthy. Thank you for the miracle, which is this rapid development of multiple highly effective vaccines. It's amazing. Never before in history. We're grateful. Amen. Okay. Let's connect everyone on Eclipse. And while we're trying to manage all that, let's get our, we'll also go over a calendar, but let me share the project. All right, class 22, that's today. We're good to go. We're going to bring everyone that's currently logged in. There we are. And we've got although it's a new project, it's got the same material as last class. So we'll let that settle out for a second. And while we do that, we'll review our calendar. So I'm getting our calendar ready to go and bringing the calendar up on the screen. Okay. All right, our class is showing. Today is March 3rd. You've got a programming assignment due tonight, which is related to trying to find the tweets and the keywords. Had some good conversations during office hours with some of you about, in particular, the alphabetization of your tweets. So after you pull out the tweets with the keyword, you need to alphabetize them, and you need to alphabetize them in a case-insensitive manner. And so the key to that is a method that's present within the collections class called sort. And if you call collections.sort, that will do the work that you need it to do, but it will not do a case insensitive sort. So let's see, switching over to Eclipse real quick. Let me just show you the magic sauce for how you do a case insensitive sort. Actually, I'll show you that in a second once we get everything lined up. We have an exam covering everything up and through Chapter 7 a week from Friday, so before spring break. So that's coming. You probably have a lot of classes that have exams coming up before spring break. So take the time now to start front loading your studying and your preparation. Exam 2 will be open book online, similar format to the last one. It will be cumulative. So it will be cumulative because it's very hard to have any kind of computer science exam that's not cumulative, because we use the tools and techniques that we relied on previously in order to develop the next level of tools and techniques. Today we're talking about chapter 15, though. It's our second lecture about the Java Collections Framework. And we're going to start getting going on that. Let me just see if there's anything else on the agenda here. Okay, so far so good. So let's go over to Eclipse and see how we're doing with joining our classmates and our code together. All right, let me run through and do some read-onlys and do one more check. So Addy, read-only. Ben, read-only. Ben F. Ben A, read-only. Ethan Vaughn, read-only. Ethan Banyas, read-only. Okay. Landon, read-only. Matthew, read-only. Dee Dee, oh, Sam jumped. Read-only. Dee Dee, read-only. Thomas, read-only. All right, what I'm going to do is I'm going to show you what I was talking about with respect to the collections and sorting in a moment. And then we'll try and bring the folks who weren't online or hadn't connected yet in a moment. All right, so if we go to our Robinhood example, last class we created a brokerage in order to demonstrate how we could sort through an array list. Here's an array list. If this were tweets, this would be how we get our existing tweets. We store them in an array list, which consists of a list of stock accounts, and we're calling that reference accounts or that variable accounts. Here we were demonstrating how we could create a separate one to capture the ones we cared about, which was the ones with GameStop stock. And then we went through and we iterated through our original data here, and we checked to see if any of them had a particular stock in it. And if it did, we added them to that particular stock. All right, so now this is our accounts with GME is a list that has stock accounts. So if we try and sort that collection, if we say collections.sort accounts with GME, there it is. What did I do wrong? Did I not? I need to import it. Okay, imported. And what's the problem here? Okay, cast argument accounts with GME. Did I spell it wrong? What did I do wrong? Cast it to a list. It is actually a list. Got that part. All right, let me think for a second. All right, I'm just going to talk out loud and work my way through it. Okay, so as I hover over here, it seems to think that accounts with GME is not actually a list. And when I look up here, it looks to me, sure looks like it's a list to me. So when I come down here and I do that, I'm not exactly sure what's going on. All right, let me just talk it through one more time. So up here, I'm creating a variable called accounts with GME. I'm using the same, am I using the same variable name? Yep, there we go. All right, so that's the name of the variable. It is instantiated to an array list, and it is of type list, and that's all fine. I come down here, and when I try and sort it, I get this error. And when I hover over it, Eclipse says the method sort that requires a list in the types collections is not applicable to, oh, I know why that is. That's because exactly what I'm trying to prove. So collections is unable to sort this list because it doesn't know how to compare two stock accounts. If it was two strings, it could compare it alphabetically and it would know how to do that. But if you ask to sort a list of stock accounts, it doesn't know what you want to sort it by. It doesn't know whether you want to sort it by the dollar value of your stock account, or whether you want to sort it by the name of the owner, or whether you want to sort it by how long the account has been in existence. There are all kinds of possible ways that you could want to sort a list of stock accounts, and so it's not clear what that is. So what I'm going to do is, just for the purposes of demonstrating what you need to know for Episteme 7, is I'm going to change this to a list of strings, an array list of strings. And then down here, when I check to see whether an account has the stock, I'm not going to add the account. I'm going to add the account number. So it's not going to be a list of stock accounts. It's going to be a list of strings because the account number is a string. And now when I get down here, when it asks to sort accounts with GME, I don't have a problem anymore because we know how to sort, or Java knows what to do with strings. It sorts them alphabetically. But it's case sensitive right now by default. Here, let's clean this up so that it works correctly. An account is a string, so we don't need to get the account number. All right, so here's the problem. This is sorting case sensitive. And what I asked you to do in the assignment was to sort by case insensitive. So to sort case insensitive, you have to do something which allows the sort function to know how to compare the strings. If you don't want to do it the default way, you have to tell it, well, how do you want to do it? And you have that, if you want to do that, you have to provide something called a comparator. And a comparator is a function that will tell the Java collections framework how it is that it should be comparing the two strings. And string itself comes with such a comparator, and so you can just pass in the case insensitive order comparator to the end of sort. And that will sort your accounts in case insensitive order so that capital A's and lowercase a's are adjacent within your list. That's the fast answer. Now you can write your own comparator and replace it here for string.case insensitive order. That would be foolish for this assignment because this is so easy. But it's necessary if you have something like a stock account and you do want to sort your stock account in order of maybe how much money is in the stock account. Or if you do have statuses and you want to sort them by most popular to least popular rather than by trying to sort it by the alphabetizing the text or something, then you do have to provide your own comparator. But I offer that to you because this is a really easy way of doing your sorting in a case insensitive way. Okay. Great. All right, so that was the first thing. Now let's go through and see if we can get the rest of the folks online here that weren't attached the first time. There's Ben A. and Carson, Ethan B., Frank, Josh, Monty, Morgan, and Trent. All right, we'll let that settle out. And while that's settling out, we'll go ahead and pick up where we left off last time. We know that when we looked at Eclipse, we had this relatively new syntax, which we can see highlighted here on lines 15 and 17, where when we use one of these Java collections frameworks, we separate out the idea of two things. What is the behavior of the data structure that we want to invoke? And so here we have the examples of the list behavior. We have one particular way of implementing the list behavior called an array list, and we have another way of implementing our list behavior as a linked list as well. We haven't seen that yet. We have one behavior of how we want these things to work, which is to keep track of things in an order. And then we have what is the type of the things that we're keeping track of. So this is like saying, hey, I want a train with a lot of containers in it, and this is what I'm going to put in the container. This is like a boxcar, and string is like coal. And together, you need these things together. A train with boxcars filled with coal is your type. And then you're able to work with it. So this diamond syntax, which is what the book calls it, I'm not particularly fond of that name, but this is called generics. We use a less than symbol and a greater than symbol, and it's described as the diamond syntax within the context of our textbook. It's a convenient way to provide specifications to our array lists and what we call generic classes about what is present in our different Java collections frameworks, or different data structures. Lists, sets, maps, queues, linked lists, all these different kinds of collections. Here are two examples of using it. The top yellow box is an example of using it, where on the left side we specify what the type of our variable is. It's an array list containing strings, and it's called names. And on the right side, you can see that we've left the diamonds unfilled. We've left them with nothing in there. It's not that Java doesn't need it there, it's just that it can figure it out. So the top yellow box is shorthand. And what happens here is that Java says, oh, your variable needs strings in it, so I can assume that the thing over on the right has to have strings in it. That's just shorthand instead of using the second yellow box when you're explicitly saying what's going to be in each one of the types. I'm personally fond of using the second yellow box and just being explicit about what our constructor is calling and what our variable is calling, because I feel like when I read the code at the bottom, with a little bit of experience, of course, I don't have to spend as much mental energy understanding what's happening as I do with the first yellow box. In the first yellow box, I have to spend some time figuring out, oh, what is Java going to assume is in my array list? If I look at the right side, to go over to the left, I have to see what the variable type is, and then I have to move in my head string from left to right. Whereas in the bottom, I just see array list string and I know immediately what's going on. So you can do either. The diamond syntax is at the top. I just prefer the bottom one. I feel like it's just a little bit more OCD complete. Okay, and the reason why it's called the diamond syntax is because putting a less than symbol and a greater than symbol next to each other looks like a diamond. All right, so let's look now at a second kind of list structure called a linked list. Let's go over to Eclipse and do a little example of it, and then we'll walk through. Let me find those folks who have added and move into read only for a sec. Okay, that's Ben and Carson and Josh and Morgan. All right, and now what I'm going to do is I'm going to create a new package that is going to hold what we had last time. Dash last class. Okay, and then I'm going to move everything that's currently there into that package, and boom, there it goes. So it's available to you if you want to look at it. And then what I'm going to do now is I'm going to make a new class for today's stuff, and we'll call it Java Collections Framework Demo, and it's public, and it is in the next level package, and we want a main function, and we're going to finish. All right, and you can see how in the package explorer it is smart about how it shows me the different directories. It only shows me those directories that I need to see in order to separate out the two different locations of my classes. So I'm in the Java Collections Framework demo, and we can make a bunch of variables. Let's go ahead and create some. So we're going to create an array list, which will have it contain strings, and we'll call this A because I'm going to do a bunch of them. And that's going to be a new array list of strings. And let's import that so we don't have any errors. And then let's create one B, and we're going to make B be a list of strings. And we're going to have to import that. And we can say this is okay to do because list is a parent in the class hierarchy of array list. So we're good to go there. All right, let's do this structure again. And with C, what we're going to do is we're going to create a new linked list. This is a different way of implementing a list. It has the same behavior as any list, but it uses a different underlying technology we're going to look at in a second. And you can see that both linked list and array list, as demonstrated by lines 11 and 14, both B and D are the same type, but they're both created with different instantiations along the way. They're implemented with an array list and they're implemented with a linked list, but both of them conform to the list interface, and so you can do the same things. Everything that a list you expect from a list can be done with an array list or a linked list. All right, let's do the same thing. Let's make a set, and let's use one technology for a set called a hash set. Make that E. Constructor there. And we can do the same kind of business we did previously with the interface of set. Make that F. And there's a hash set, and let's import it. Import and import. All right, that's two examples of implementations of a set. And now there's a second kind called a tree set, and we can create that, make that G. And import it. All right, and you can see that both F and H are both of set type, and they are implemented with a hash set and a tree set. So those are all different things we can do. And then we know that collections is a superset of all of them. And so we can say collections of string, we'll say I. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8. All right, so I, J, K, L. Oh, I kind of screwed that up. I, J, K, L. There we go. M, and import collections. And I'm just going to show you that you can make them all be collections. Hopefully I'm doing this right, although for some reason what's happening here. Remove type argument. I guess you have to use the right name. That's one of the things about Eclipse. You have to use the thing that you have to use the proper name, not just what you want. Okay, and there you go. So in writing this code, what I've demonstrated is that there is an inheritance hierarchy, that I, J, K, L, M, N, O, and P are all the same type. They're all examples of a collection of strings, but what I'm implementing them with is different. I'm implementing them with an array list, a linked list, a hash set, and a tree set. That's A, C, E, and G. I'm also assigning them just lists and sets as well, because collections are supersets of lists and sets. So when we come down here then and we say, okay, let's add something to a collection. Let's add hashtag Dodger. I don't want to have to do this over and over again. All right, I, J, K, L, M, N, O, P. We added Dodger to each one of those sets. Now what's going to happen, well, in this case, it's all going to be the same, I guess. Let's repeat that now to second thing. Let's add the same thing again. And then let's add the same thing. Let's add something else. Dodger, hey, does anyone have a pet that we can represent? Someone unmute and tell me your pet's name. Oh, we're typing. Who is it? Whose pet are we going to represent? Billy. Okay, Billy. Is Billy really your pet name? Is it a goat? A gecko. Okay, good. All right, Billy the gecko. All right, so Billy's going to get represented here in our set. All right. All right, so in each one of these cases, we've done three things to each set. We've added Dodger the first time, we've added Billy the second time, and we've added Dodger the third time. So now if we come down here and we do fast enumerations, let's put a tab and then the actual string, and let's preface it and say, all right, RJ, go through J, RK, go through K, RL, go through L, RM, go through M, RN, go through N, RO, go through O, P, go through P. All right, so what I'm trying to do here is I'm trying to demonstrate to you that although we have 1, 2, 3, 4, 5, 6, 7 different, 8 different collections, which are all of the same type, collection string, because they're implemented in different ways, we're going to see different behaviors for these collections, but all of these collections have access to the same methods. And so after defining these collections, we're going to add Dodger to each one, and then Billy to each one, and then Dodger to each one. But then we're going to see that they get output in different ways depending on what the underlying technology is, if all goes well. I'm doing this on the fly, so we'll see if it does what I expect it to. So we're going to run it as a Java application, and everything, let's see how it goes. Great. All right, and let's see if we can show this on the screen. Great. All right, so let's look at what we've got. So I shows Dodger, Billy, and Dodger. That's good because I and J were implemented with array lists, if I remember correctly. K does Dodger, Billy, Dodger, Dodger, Billy, Dodger. That's good because both of those are implemented with linked lists. So first two array lists, second two linked lists, all four of them are the list interface, and we expect list interfaces to behave the same with respect to the way in which they keep track of elements in the list. Now, we come down to a different situation here where we end up with four sets. Actually, you know what? I need to change one thing so that we see a difference between tree sets and hash sets. I'm going to come down here and I'm going to add Billy first. And then Dodger twice. Is that going to matter? Yeah, it will matter. All right. Let's run it again. All right. So we changed the order, and the list respects the order that we put it in. Billy, hashtag Dodger, array list. Billy, hashtag Dodger, a list implemented as an array list. Billy, hashtag Dodger, a linked list. Billy, hashtag Dodger, a list implemented as a linked list. Now, I didn't do what I wanted to do. Oh well. Okay, now we get down into the sets. So we have an array set, and we have a set implemented as an array set. And you can see that in both of these cases, they kept track of the unique elements that are present within the set. Down here in O and P, we were implemented with a tree set, and they also kept track of the unique elements within the set. So when we added the second Dodger, the sets just disregarded it because the set already had an example of hashtag Dodger. All right, so that's just a little example to try and work through some of the ways in which the collections work happens. What we don't see here is we don't see an example of a map. Okay, so call an audible. I will leave this to you folks. Do you want to look at examples of maps in Eclipse first, or do you want to go through the textbook work on linked list first? Choice is linked list or maps. First 3 or 4 people that type into chat, I'll go with. Maps. Any counter vote? Maps. Maps it is. Maps. Three or 4. Okay, wow, great. You all are excited. All right, good. All right, so here we go. We have some examples of code that's present in the linked list. All right, what I'm going to do is I'm going to rename this function, and we'll just call it main old. And we'll create a new main function, a proper main function here. And we'll implement a map. All right. So a map, you know, is a relationship. Well, you should know because it's like a dictionary in Python. It's a relationship between two different types. So when we work with the diamond syntax, we have to specify what those two types are. So let's say we're going to work with kind of a bank account model, and we'll say that we're going to have unique integer account numbers that are going to map to someone's name. All right. So we'll have an account number and then an owner of the account. And what we'll do is we'll start with an example of a map, and we'll say a hash map. And let's make sure we can import. Let's see, we need to instantiate it. Okay. And so what we have to do in our generics is we have to specify what is the type of our key and what is the type of our value. Give it a name, and we'll call it our, what are we going to call it? We'll call it our account lookup. All right, and now we have an example of a collection, a hash map that is implemented as a map. We'll show you how to use it in a second, but let me demonstrate how the collection aspect of it works. So just call that A to demonstrate, I don't know, demonstrate the inheritance hierarchy. I don't have better names on the fly. All right, we could also use a tree map. Tree map is a different implementation with slightly different behavior. And we'll go ahead and put this, give it a 1, and give this one a 2. and we're going to implement it as a tree map. All right, so now we have 4 different references: account lookup 1, A, account lookup 2, and B. Account lookup 1 and A are both of maps, but there are 4 different data structures that we're working with here. So let's imagine that we want to add something to our first account lookup. What we would do is we would say account lookup 1, and when you use a map, you don't use the add word, you use a different word called put. And that, I don't know why that is. It's just to remind you that you're using a map, I suppose. So we'll map the integer 1, and we will map it to Professor Patterson. And we now have a data structure in which there is a linkage between the number 1 and Professor Patterson. And now let's do it 2, and we'll throw Dodger in there. And Billy recently got a gift from his dad, Ethan. I kind of like saying Billy the Gecko, so I'm going to just say Billy the Gecko. It's not just Billy, it's Billy the Gecko. 3 different accounts. And now if we're interested in cycling through them, we can do a couple things. We can say, for example, we could say string name, and we can do a lookup. We can actually look up in the data structure. We can use get, and we can say, hey, who is at position 2? And string should be equal to Dodger. All right, and you may recall that we used a different kind of square bracket or curly bracket notation in Python to get that. We just used the get method in order to do it, in order to pick that up. Now, if we want to go through all of them, we can also do a fast enumeration. There are a couple different ways of doing fast enumerations in a map, because you have to ask, well, what am I enumerating over? Am I enumerating over the keys, or am I enumerating over the strings, or am I enumerating over the relationships? Typically, you want to enumerate over the relationships, but let me get there. So the first thing we're going to do is we're going to enumerate over the keys. And so we know our keys are integers. So I'm going to say integer key, and we're going to go through account lookup. But account lookup isn't a set of keys. We have to ask for the keys from our account lookup to go through it. And so we ask for the key set from our map. And then our keys one by one will list out all of our keys. Let me just demonstrate that, and then we'll go from there. All right, let's run that and see what we're getting. All right, so who is number 2? Dodger. Here are the keys: 1, 2, 3, and 4. Oh, sorry, just 1, 2, 3. Get a little ahead of myself. That's fine, but I would also like to know what the value is. So we're going to go ahead and change this. So we add onto it what the value is, and each time we get a key, we're going to look it up. So this is an example of going through each one of the keys in our map by looking at the key set, printing out the key, and then printing out the value associated with the key by using the get lookup command. So we'll run it. See, 1's Professor Patterson, 2 is Dodger, 3 is Billy the Gecko. There is no reason why these necessarily have to be in this particular order. I think they're going to, I'm not exactly sure. If we put 3 in the first one, I'm not exactly sure what we're going to get. The order is not defined in a hash map. We're getting the right order out. Well, that's great. It's in a tree map, you're going to get the order of the keys, but you're not guaranteed to get them in the right order. We happen to be getting them in the right order, but you're not guaranteed to get that. Okay, so that's one way of doing an enumeration. I feel like that way that I just showed you is the way that's most relatable to the things that we've learned so far. We fast enumerate through the keys, and each time you get a key, you look up the value. That seems most comparable to what we've done so far. I would say that there's a slightly better way of actually doing this, though, if you are doing enumeration through map. This is sort of the standard way of doing it when you need the key and the value. So instead of watch what I do here. This is a little bit of a Eclipse hack. All right, I'm gonna comment this out. I'm gonna try and get Eclipse to write as much of this code as I can for me. So I'm gonna say I want a variable called data that is going to range over my map called account lookup. All right, so Eclipse can't do anything for me if I haven't actually told it what I want to range over. And then I have to declare what I want to range over. I could put key set in here. I could put values in here. What I want is I want the entry set. All right, so I haven't explained what that is. But now what I'm going to do is I'm going to have Eclipse provide the type of the data variable for me by looking at code completion, and where it says create loop variable data, what it's going to do is it's going to put the type in front of data so I don't have to think very much about it. And you can see that data has this unusual type. It is entry, and then it's an integer and a string. It is a class called entry, and it has two different types, just like a Java collection framework. And then I don't have to do a lookup down here. I can just say data.getKey and data.getValue. It's like a tuple. If you remember tuples from Python, data is like a two-element tuple if you want. So that's kind of how it's done more generally in professional code. Okay, we get the same thing. Keys, Professor Patterson, hashtag Dodger, hashtag Billy Getgo. All right, let me pause for a second and get questions from the peanut gallery out there. I see that the animation is working very successfully in some regards because Landon is lying on the floor underneath his chair. So hopefully that's like the animation and not a sign of despair. All right, I'm double broadcasting for a moment. Thank you. I need like I need someone to have the official role of like audio disciplinarian or something. All right, back to YouTube. Awesome. All right. So briefly went off audio in YouTube, and now coming back, what I'm doing is I'm flipping the relationship between the key and the value to demonstrate how when we get something from a map, we're not using the index of the element, we're using the relationship, the key relationship. So to do that, what I'm changing here is I'm changing the relationship for account lookup 1 so that it maps a key to an integer. And so now the idea is that we're going to look up someone's name, use a key, their name is a key, and we're going to look up their account number. And let's not use sequential numbers for this. Let's use some other kind of larger number so that we demonstrate that the account numbers don't have to be sequential necessarily. So now when I look someone up in the code, I'm going to look them up by I'm going to look them up by their name, and what I'm going to get back is their account number. Um, and this is what is Dodger's account number. All right, so this should all work fine here, except that I just have to change the type of key to be string. We're okay. And then down here, this should work fine. I just have to change the relationship between key and integer. All right, and so I've done something kind of tricky here. I just swapped the two types around so that now the keys are strings and the values are integers, and the code should work fine. The output will be a little bit different. All right, so we see what is Dodger's account number? It's 222023049. What are the keys? It's going to be hashtag Dodger, Professor Patterson, Billy the Gecko, and then we have different integers that are associated with each of them, looking it up. What are the keys? Now we're doing the entry enumeration, fast enumeration, Dodger, Professor Patterson, Billy the Gecko. All right, the difference between these two loops is whether I am enumerating over a set of integers or whether I am enumerating over a collection of entries. All right. So that was all to make the point about linked lists. Linked lists are a different way of implementing a list instead of an array list. It keeps the same behavior as a list, meaning we have individual elements in our list that we can access by the index number, starting at 0 and going up to whatever the length of our list is, -1. Keeps track of a sequence of objects. The reason why you might choose a linked list instead of an array list is because one is more efficient than the other at certain methods that we might call in our list. A linked list has a very efficient addition and removal of elements within the middle of a sequence. Each node keeps track of the next node. In the implementation, you don't have to worry about this right away, but in the implementation of a linked list, the way that we manage it is we have nodes which have references to the previous and next one. Rather than keeping them all together in memory, we have references that go to the next one. And so we keep track of what our next node is, and a good metaphor for this is people holding hands. And that's why this picture is here. It is like each person is a node holding data, and then in addition to the data, you've got some connections that go to your next node that's holding your data. And so in order to find the next element, you have to go from one person to another, finding who they're holding hands with. And that takes a little bit of time because you can't just jump into the middle of memory. But what you can do is if you want to add a new person to that list, it's really easy because two people next to each other can just let go of their hands, hold hands with the new person that wants to be in the list, and now you have a list that has a new element in it that was very fast. All you had to do is break one connection. All right, so adding and removing elements in the middle of a linked list is very efficient, but visiting all the elements of a linked list, visiting the elements in a sequential order is efficient, but random access is not efficient. What random access means is accessing different elements by their index number randomly. So going to 5 and then 2 and then 3 and then 1 and then 100 and then 40 and then a million and 10. Jumping around like that is very inefficient in a linked list because in order to get to each element, you have to walk through the entire list in order to find the element that you want. Visually, you can look at it this way, and there's a data structure underneath that maps to it that is actually implemented very much like this. We have a link from Tom to Diana and from Diana to Harry. That's an example of a linked list. And there's also a link going backwards if it's what we call a doubly linked list. All right, so the reason why inserting and removing is fast is because if we have a new node we want to add, Romeo, the Shakespearean tragic hero, we can drop Romeo in between Diana and Harry. Notice it's not alphabetical or anything. It's just someplace that we choose to put them into this list. Because remember, a list is just about keeping track of some order, not an alphabetic order necessarily. So this order is something we care about, but it's not a sort order. It's just maybe these are the priority of who gets to check out books or who, I don't know, who's next in the, in the DC line for salad. We want to add Romeo. We have to break two connections, the connection from Diana to Harry and the connection from Harry to Diana. And we redirect those connections so that they're pointing at Romeo. And then we take two connections from Romeo and point them back at Harry. We don't have to do anything with any of the other connections in our linked list. And so that's what makes it efficient. If we want to remove something from a linked list, it's also efficient because what we can do is we can redirect Tom's link to skip Diana and go directly to Harry. And we can redirect Harry's link to cancel Diana and jump over her as well, leaving the linked list connecting Tom to Harry and Harry to Tom and Diana hanging out like the third wheel in the relationship. Jumping and getting any particular element is hard because we have to walk down the entire list in order to find the particular element that we want. We can do it because we have to be able to do it for this to be considered a link. It's just not efficient. Okay, so when do you want to use a linked list? And we talked about this briefly at the end of last class. You have to choose an implementation when you want a list. How do you choose which implementation you want? Well, you want to use a linked list when you're concerned about the efficiency of inserting or removing elements. If that's the thing that you're going to do most of the time, you want to use a linked list. And you rarely need to just access little individual items cherry-picked from your entire area of your linked list. Walking through your linked list is fine. That's not particularly slow, but accessing individual elements bouncing around is a problem. Okay, so we looked at the implementation of this briefly in our code, so I don't want to belabor this, but it is also a generic class, meaning that when you declare a linked list, you have to specify what your list is going to be keeping track of. We saw examples of keeping track of strings, but you can keep track of any class you want. For example, you can keep track of Twitter status objects, or you can make your own object like we did with our brokerage class count. What did we make? We had brokerage, and then we had a stock account. So we could have a list of stock accounts if we wanted. Anything you wanted. You could have a list of, a music locker with different songs in it. You could have a virtual dumpster if you wanted, filled with trash. Whatever kind of class you want to make, you can have a linked list full of it. Linked list is implemented in the java.util package, so you may have to import that. And you could see that when I was writing my code, I know that linked list is available, and so when Eclipse gave me an error, I asked for a quick fix, and I looked for the import java.util option in the quick fix, and Eclipse cleans it up for me. I don't spend a lot of time worrying about that as a programmer because I know what a linked list is, and I know where I expect to find it. Linked list has all of the methods from the collection interface that are available to it, but it also has some additional methods that are unique to a linked list. So here are some examples of them. Let me see if I can zoom in so we can see it a little bit better. For starters, we need to be able to create our empty list. And so in this first row in the blue, you can see we're using the diamond syntax to imply what's going to be in it. Hashtag do not like, 2 out of 10 would not recommend. However, it is legal. And I won't take points off if you do it. However, 2 out of 10 would not recommend. A couple other methods that you have available to you is you have a method called add last. So that explicitly adds something to the end of your linked list. And of course, add will have the same behavior. If you want to add something to the beginning of the list, linked list implements a different kind of method called add first. Now that's not available in your collections method, but it is available in your linked list method. Add first will put something at the beginning of the list. Likewise, you can specifically ask for get first and get last, which will get the first and last elements. These are additional methods in addition to those that are available in your collection class. You can remove your first if you want, and that is an additional element available to your linked list. We can also get an iterator for visiting all of our list elements, and we haven't really looked at how list iterators work yet, but we're about to. Let's just go over to our code real quick and demonstrate how those different versions, what's happening here? Look at how those different additional methods are not available in all of our examples here. All right, so what I want to demonstrate is that we have array lists and lists, linked lists and lists, hash sets and sets. And so let's just put in some code here after line 51 and demonstrate that we can say in C, in the variable C, which is of linked list type, we can add something to the beginning. So add first, hashtag Billy the Gecko. No, it's not hashtag, Billy the Gecko. I love Billy the Gecko. Billy the Gecko is my new favorite. Second favorite. We know who my first favorite is. All right, so add first Billy the Gecko. D, we cannot add first. We cannot add first to D because what type is D? D is a list, and list does not have an add first method. Likewise, down here in I, we can't add first either. Because I doesn't have an add first method, only a linked list does. Furthermore, up here, we can't add first to an array list either. I hope. Yep, there we go. Because A, which is an array list, we can see up here on line 47, that does not have add first. Add first is just a linked list method. B is a list, and we can't do that because add first is a linked list method. It only works for C because C is declared as linked list, and therefore we can add first. So we do have the ability to have some additional power when we do a particular implementation and we retain the type of that implementation in the declaration of our variable. Wow, this time has gone very fast today. All right. We are approaching the end of our class. Okay. Yep, and that's great. Good class. I enjoyed what we covered today. I really like generics. I think they're awesome. We need to talk about list iterators. We need to talk about some algorithms. Let's see how we're doing on our calendar. I just want to see what we've got for time here. All right, evaluating our classes going forward. Chapter 15, where are we? Okay, well, we'll make do. All right, next class is going to have to be a big one. So we'll blow through a bunch of stuff. Great, we can do that. It's probably going to take some effort on you all's part to make sure that you are following up by reading your textbook and doing some of our examples to make sure that you're understanding the techniques. There's a lot of different different data structures covered in this chapter. All right, so let's see. Back in game to just reiterate what's going on in game. Let me go back to in-game broadcast. Okay. We are double broadcasting. Let me single broadcast. All right, so this is for the purposes of our YouTube recording. It is March 3rd. We are ending our class. Today we talked a lot about lists and collections, generic types, and we've got a new checklist, new attendance board. Excited for a new week. Take care. See you next time.